Sometimes we have to use our understanding of math in order to come to a conclusion when we're solving an equation like this one right here. We've got 5 going into 27.02. So what we do is we just go through our basic division principles. Obviously 5 doesn't go into 2, it goes into 27 5 times. 5 times 5 is 25. 27 minus 25 is 2. We bring down this 0. 5 goes into 20 4 times. 4 times 5 is 20. We're left with 0. And we bring down this 2. And it leaves us with a little bit of an unusual situation because now we can see that 5 clearly does not go into 2. Now typically when we're using whole numbers, we would simply say remainder 2. But because we're dealing with parts of a number, we can actually manipulate this further to get a more accurate and definite answer. And the way that we do that is simply by saying 5 goes into 2 0 times. 0 times 5 is 0. Subtract, and we end up with an answer of 2. Well, what we know about decimals is that no matter how many zeros I put behind this, it is not going to change the total value of the number. So I can simply put a 0 here and then bring it down, and now I can go 5 into 20, a total of 4 times. 20 minus 20 is 0, and we have solved our equation at 5.404. Sometimes when we get a division equation, we're going to run into a situation where we have a repeating decimal. In this case, we have 9 going into 3.3. So we just go through our simple process of long division. To realize that we are going to run into a situation where we've got 9 going into 50. Well, we know that 9 will go into 55 times because 5 times 9 is 45. But now, all of a sudden, we're left with something kind of unusual because our answer is bringing us back once again to 50. This process, we can tell, is going to go on forever and ever because no matter how many times I put 9 into 50, it's still going to go in 5 times. And I can continue to add zeros down here forever and ever, but it's not going to change the fact that this answer is going to be 0.35555 and as many 5s as we can imagine forever and ever. Now, rather than continuing to try and add this out, we can simply stop the problem once we recognize that there's a repeating pattern and simply indicate that the pattern repeats by placing a bar over the digit that continues to repeat. Now, if you have more than one digit that continues to repeat, then you need to make sure the bar covers all of them. If you remember what we did at the very beginning of this lesson, we started to realize that we can manipulate decimals without actually changing the outcome, as long as we're moving the decimals in both numbers in equal number of spaces. In this case, we have a decimal dividing into another decimal, and that can be tricky to operate with. So what I'm going to do is I'm actually going to move the decimals in these cases without actually affecting the outcome. Because right now we know that 2.4 divided by 0.6 on a calculator is going to end up giving us an answer of 4. Check it out on a calculator if you'd like to. So what I'm going to do is I'm going to simply take this decimal and I'm going to move it one place to the right, which essentially gives us a new equation. It changes it from 0.6 to 6, and from 2.4 to 24. And when we do 6 into 24, we can tell that it goes in a total of 4 times. Okay, let's check out this example because this helps illustrate the purpose of moving decimal places. Now we've got a situation here where in order to move this decimal place over to turn this number of 0.009 into a whole number of 9, we would have to move it a total of 3 decimal places. 1, 2, 3. The problem is that I've only got one decimal place to move this decimal as of right now. But if we remember correctly, that this blank space is actually occupied. It is occupied by zeros, because we can add as many zeros to this equation as we want, or to this number as we want, without actually changing the value of the number. So 7.2 is the exact same thing as saying 7.200. Well, now that I've added these zeros in, I can simply move them 3 spaces, and I can place my decimal point directly above. And now I can proceed to divide as if this is now 9 into 7,200, which is going to be a much easier equation to work with, considering the fact that we know that 9 goes into 72, total of 8 times. Bring down the 0. It goes in, 9 goes into 0 times. And it goes in a total of 0 times. And we are completely finished.